So when we're looking at wind erosion processes, we're talking about detachment, entrainment, transport, and then deposition of those soil particles. So the detachment's really the important part that we can focus on by using different approaches of residue cover, by trying to build the soil particle size so it's less likely to be detached. We can look at using wind breaks to reduce the wind velocity at the surface. So really the detachment is where we're focusing, and then the transport and the entrainment and the deposition is another part where you can do some efforts, but you really want to focus on trying to keep those particles from being detached. So one way to decrease detachment is by increasing your particle size. So the larger the particle size, or the larger the mass of soil that you have, whether it's a clod or it's an aggregate or something like that, the less likely it is to be actually detached from the soil surface and picked up by the wind and moved across the surface.
When you talk about erosion out there, the way that water, when you talk about detachment, the way that water and wind can take that soil is because of the tillage that we do. And the smaller the particles it makes, the easier they blow away. So we try to help farmers just reduce their tillage, reduce the amount of passes, reduce how deep they go, how aggressively they are, to try some spring tillage, especially going into beans instead of fall tillage. And really think about the soils that they have out there. So the field that we were in, you can really tell where there was a lot less tillage that had been done, and more residue on the soil surface was trapping that soil, was keeping it there.
So we have a couple different processes where you have saltation, you have creep, and you have suspension. So saltation is the bouncing of the particle across the surface, where it's dislodging smaller particles and allowing those to be picked up by the wind. Creep is where it's rolling across the surface. Suspension is where that particle is actually being lifted into the air and carried far distances. So your clay particles would be suspended. Your larger aggregates may creep across the surface, or they may stay in place. Your sand particles may saltate or bounce across the surface and dislodge other soil particles. So the larger the particle, or the mass in the aggregate, or whatever you can do to make those particles aggregate together and hold together, the less distance they're going to move across the field.
You can picture this field being the expanse of Red River Valley all the way to Montana. In 1929, almost all the fields in North Dakota were worked to this extent, and actually this field has more residue on it than those fields did at that. So you can imagine when the soil dried and then the wind started to blow, how horrific the effect of that must have been, with no tree rows, no conservation tillage, none of what we have today. The sad thing about this is that it's not the 1930s, and we have the equipment that's available, and we have the resources available so that we don't have to lose soil like this. What happens in the wintertime here is an open winter, and it's not a rare thing, it happens in North Dakota a lot, is that the top of the soil, even if it went into the fall wet, the top and the surface of the soil freeze dries. The little clumps that might be around with the tillage, they break up into very small particles because of our smectatic clays. They break up into dust, essentially dust, and they're subject to this horrible erosion.